Welcome to B&W Insights. I am your host, Mark Siefert, and today we have a great conversation with Vice President of Water, Brent Perz, and we're talking about energy neutrality and wastewater. Wait, energy neutrality and wastewater? How do those two things go together? Brent?
It all starts with an acronym, WRRF.
And what's that stand for?
You know what that mean, Mark?
No.
Water Resource Recovery Facilities. So as part of the industry's desire to put more of a focus on a resource, we retermed our plants then from wastewater treatment plants to water resource recovery facilities to really allow everyone to view what we do and the value we provide with the utilization of the resources from the waste coming in and what we can produce with the clean water and energy potential.
Ready? Let's get started. Brent, thank you so much for coming down to the podcast today. How's your day going?
It's going really good.
So you've been at Baxter&amp now 21 years. You've came up through the ranks, started in a cube, designing wastewater treatment plants, now to the vice president of the water practice. Talk about that, some of those moves you made and some of the most exciting things you've seen in your 21 years.
Yeah, and I'm even going to go back a little bit further than like my first year here. I interned for 3 summers, so worked out of my car.
Nice.
It was a great experience to get to know the team here at Baxter Woodman and really like understand what we value, the culture here, and really kind of find my home even before I got to interviewing for that full-time position after graduation.
So, when you were in college, what drew you to wastewater? Because sometimes when I go out in the field and I talk to people that like I grew up in wastewater, that's just something I grew up in the wastewater treatment plants. I grew up, being a wastewater operator. How did you get drawn to wastewater? As many people are like, how can you do that and smell a wastewater treatment plant all your entire career?
I feel like as a junior and senior in high school, I was like very unsure. It's like a big decision to choose what major you go into, and I hear all these people like they change majors 8 times, and I'm like, I'm gonna pick the one that I'm gonna be with for the rest of my life. I went to like a counselor, and he like created like a matrix of all these answers.
Very engineer.
And I'm like, this is right for me. And then he's like, you're great in math and science. You love the environment. You appreciate a lot of the values that are associated with environmental engineering. So that kind of led me to that engineering field, and then kind of like chose my college and then really stuck with it. And I thought the civil engineering with the environmental focus with a lot of the water treatment, wastewater treatment was really like my home.
Nice.
So I guess after like selecting Baxter Woodman, going through that like matrix of college selection, had a career fair at Iowa State, got an internship, worked here for 3 summers, and I've worked my way up through kind of being a project engineer all the way to the vice president of water. And I would say the really cool thing about the development of, I would say myself professionally is like I feel supported in terms of finding people to like do my job and do it better than me and like allowing me to advance and grow as a professional.
Well, it's really cool that you have now, you're training people, you're mentoring younger staff. And as we talk, move into the topic of energy neutrality and digester projects and solar and CHPs, you've done some of these projects not only project management, but project engineer. And I've seen you talk about some of these projects before, and it's something I can tell you're passionate in. And why is energy neutrality such a passion that you enjoy talking about and working on?
I think the energy focus comes from the competition of resources that communities have. So looking at rates, looking at the infrastructure they have and the condition it's in, it's always trying to do more with less. And if you can reduce some of those costs in terms of your energy bills or the rate at which you have to replace pumps because you can use them more efficiently, it allows you to do other things there.
So taking a simple step back, when we say energy neutrality, we talk about it, we hear it, it's somewhat of a buzzword now. Mm-hmm. What does it mean to you? And really, can you explain it to our listeners who maybe hearing this for the first time and say, how do I become energy neutral? How do I look into this? What does it mean to you? And really, what's that base ground level definition?
Yeah, I So when I think of it, I think when people talk about energy neutrality, they think about it as like a thing. Like it's just like an end result. I think of like when a kid is in a kindergarten class, they're like, what do you want to be when you grow up? They're like, I want to be the president, or I want to be a fireman. That's like they're seeing the end product of like what you get when you actually get there. But like the energy neutrality, I think is more of like a journey or like a path of what you need to commit to get to that end product, which I think is maybe the more exciting part and the more like the manageable task that everyone can do rather than just being energy neutral. Because if you go from where you are now to energy neutral, everyone's like, we can't get there.
And I'm shocked, actually, first off, that you didn't say kids in their class raise their hand and say they want to be a wastewater engineer.
Has anyone ever said that to you?
No, I've never heard anybody under 25 say that. But you're right. That path is what really helps communities get to energy neutrality. And now when we say energy neutrality, that means that they're using renewable resources. They're not using more resources than they have, or what does that end goal look like?
So I would say there's like a holistic definition in terms of like all of the inputs and outputs at a treatment plant, and then there's kind of the energy focused one. And the holistic one, I think, is a really like a carbon footprint. And the energy neutrality, we're looking at more of like the power usage in and out, and then kind of what you can generate on your site.
And when you say generate, that's using sludge, that's using gases, that's using those things you have in the plant?
Yeah. So the most common way to generate energy is through our anaerobic digestion, producing that biogas, cleaning it, and then using that biogas to run a generator to produce electricity.
All right.
Also, we've been seeing a ton of solar, and that's like a utilization of the resource of space at our treatment facilities. We have a lot of facilities that have open space. Maybe it's not ideal for process, where you can put some solar fields there and being able to generate some passive energy.
So before we get into some of the more technical sides of energy neutrality and the solar and the gas combustion, and what is, you mentioned 21 years, you've designed a few treatment plants yourself, maybe one or two in those 21 years, but when did you see this shift? When did you see the shift of plants going to a little bit more solar, a little bit more of anaerobic digestion, gas capturing? When did you see that shift, and what do you think precipitated that shift?
I think there's a couple things that have led to the shift. And first is the inherent availability of the technology. So like some of these pieces of equipment weren't around 20 years ago or weren't as advanced. So like limited functionality. So I guess once there's a little bit of momentum, you'll start to see that being kind of embraced at facilities. And like the interesting thought or thing that I got to do was like actually go to different countries and see some of these things in operations. Like we went to Denmark. It's a much older society, so they've went through a lot of the issues that we're going through now, like 50 years ago. So like in terms of technology and like their resources available, they're figuring out like how to use them better. So we got to go there and really see and like understand how they do things differently in a different country, kind of outside the box here. So,
and that's something we learned. We talked with Carolyn Greaves when she went to Germany on the water side, and she mentioned that the European Union and the European countries are so much more advanced on cleaning drinking water because you're right, they have an older society. So having some of these conversations that you were having 10, 15 years ago when this technology is brand new, and people, you were probably more educating more than now. It's people know what it is, right?
Yeah, so for me, that was like a big moment because I like, as an engineer, you're like risk averse. You're like, I don't want to mess this up. So like actually seeing this process, like working it, like, and like getting that hands-on kind of engagement allowed me to be like, hey, we can do this here. It may be the first time, it may be our second time, but like other people have done it. We can learn from that and we can do it here.
And that's really most important is some people don't want to step outside the box and be the first person to do it. But this has now been happening 10, 15, 20 years where the technology, like you mentioned, is getting better and better. I remember the first time we saw solar panels on a house, they were like, what are those giant things on top of the house? And you had a whole roof, and now they're getting smaller and smaller. The cars are going further and further. The motors are getting better and better. And eventually I assume this technology is going to become such that it's just standard place. Correct?
Is that a question?
That was a question, sorry.
I do think the evolution of this technology is going to continue to improve the utilization of the resources that we have.
Okay.
I do think that maybe looking a little bit outside of the fence or the bubble of a wastewater treatment plant is also an area that can lead to some innovation. And I think there's a couple things I'm referring to. Some of the fog, high strength waste. That's
fats, oils, and greases.
Fats, oils, and grease. Are we allowed to use acronyms, or do I have to say them all first?
You can use the acronym, and if I don't think people know them, I may just jump in, and okay. if I don't know them, I may just make them up. Who knows?
Good. High strength waste also. So that can be food waste. It can be excess beverage waste. It can be an industrial, medical. But a lot of those resources are available in your community. So if you can kind of reach outside your fence and figure out what's available there and how you can utilize it to really push you towards that energy neutral kind of term.
So, in the push towards energy neutrality, is it about sustainability, financial responsibility, or the ratepayer value? Or is it all three? What is the real driver?
I think the driver is all three. And I actually think there's I'm gonna say it's all three, but I'm gonna give a different answer.
Okay.
I actually think it is a very much a personal thing. So a lot of these people who are running these municipalities, they have a passion for doing their job really well. So I think they want to find a way to go over and above of just meeting their permit or reducing chemicals by doing BIOP. And there's this massive resource of this biogas that they're producing. So even though it's nothing to do with their original job description, I think it is something in their heart as they're a steward of the environment. They're we need to do this. Mm-hmm. So, and I think done right, I think it can really help out a lot of the other core functions to really do those better, allow you to have more financial backing to do those. And then one of the other things we've seen is that the communities that we work with, their staff really can step up to that challenge, get engaged, and really be passionate about it. So I think it actually helps out with workplace environment and employee retention to have that cool thing that they're in charge of, producing this energy for the treatment plant.
It's like they have the keys to drive the really nice car, but you got to take care of it. You got to maintain it, and at the end of the day, when you give it to the next generation, that car is even more classic and more special because you help the environment along the way. But we have some pretty cool projects that we've done that have taken energy neutrality and really stepped it up and really have taken it to the next level. Which projects, can you highlight that talk about some of the cool projects that we've done and you've seen and how they've taken that energy neutrality and taken it to the next level?
I guess maybe the one I'm passionate about is Kishwaukee.
Okay.
Because when we started, they were doing no nutrient removal, kind of two small separate processes, a lot of pumping the wastewater multiple times to get through the processes, so pretty inefficient. Mm-hmm. So we were able to convert them 4 years ahead of any schedule to meet their permit compliance for nutrients. Okay. And we also were able to better focus their long-term goals to be energy efficient and then start producing energy.
So what technology did they use? Was it solar? Was it what did they actually use?
Yeah. So the first thing, and this is I would say the key to any of these is to start small. So you're not risking this $5 million project. It's oh, it's not going to work.
Right.
So we were able to convert an existing tank to take some fats, oils, and grease from local haulers and feed it to the digester. And we were able to instantly see an increase in biogas production.
Really? Okay.
So one of the cool things is that we were able to reroute some of their access drives. So they have a back entrance where haulers can come in. Built them a fog high strength waste receiving station where they get probably 40 truckloads a day of high strength waste that they use to either feed their digester, and then they have some that is very carbon readily available, and they feed that right to their biological process.
So this high strength waste, it's coming from the community, right?
Correct.
So restaurants from what type of other places?
Yeah, so they were most successful in developing their program with coordinating with the contract haulers.
Okay.
So these contract haulers will go to like 30, 40 restaurants. They'll collect all the grease from the grease traps and other industries. So they can be a variety. It's not just like, oh, we're only doing Applebee's this week or Chili's next week. Do they even still have Applebee's?
Yes, they do.
Do they?
Yes.
That was my favorite as a kid, the Applebee's burger. But what's your favorite burger?
You know, I gotta go with like a good smash burger, like
Smash burger?
Freddy's.
Okay.
Yeah.
Okay. So yeah, they contacted haulers, and like once the word was out, like all these haulers would tell their buddies, be like, "Hey, Kishwaukee's got a sweet dumping station. It's affordable. You can get in and out." So that word got out that like they were set up to make a hauler's life easy.
I remember like when I was operating a plant, that was like the push and the pull. Do we allow the haulers? Do we not allow the haulers? Do we have a great spot for them to dump? Do we not have a great spot? And then if you didn't, they're always calling saying, hey, where do we take it? And then inevitably, a lot of times we found they would just be dumping it in your sewer anyways.
Yeah, they're like, go one man hole up.
Yeah, or they go to their behind their shop or whatever, and they're dumping it anyways. So a place like Kishwaukee's, you know, taking a problem that could be in this collection system and turning it into a solution at the plant.
Yeah, I'd say it's like maybe like a triple threat situation.
All
So
right.
like you're collecting this high strength waste, so they're paying you for it.
Right.
Like, and it's like not insignificant. I think some plants are up to $1 million a year in revenue.
Okay.
And then you're taking that product and you're producing more gas, which then will allow you to produce more electricity and make more revenue. And then also you're like making sure your lateral lines are clean. They don't have fats, oils, and grease. You're not getting pump station clogs. So really improving your operation of your community.
Can you talk a little bit more about how the comment you just made of you make more gas, which allows you to make electricity?
Yeah.
For those people who don't understand that process, how do you take gas, or how do you take wastes and solids, turn it into gas and then electricity?
Right. So I'll say like fats, oils, and grease. So it's like a vegetable oil or like your baking grease. It's all a volatile solid. So it's like very much it's like a carbon that can be converted to energy. So for anaerobic digestion, we are feeding that fats, oils, and grease into that process. And we are converting that volatile solid in that product into methane.
All right.
So it goes through acetogenesis and methanogenesis, and then to produce methane. So that's the normal anaerobic digestion process.
So we go super nerdy to get methane gas.
Yes.
Okay.
There's a lot of nerdy bugs in there. They're doing a good job. They produce a methane gas. That methane gas is like a very dirty methane gas. It's not like a propane you use in your camp stove or the gas in your house. So we got to clean that gas. So we remove the moisture, we remove the H2S, we remove the siloxanes, and then we pressurize it so we can use it essentially in a natural gas combustion engine that takes that. It's like an engine generator.
Okay.
Takes that gas as a fuel and then runs and then produces electricity.
Okay. So we're removing the nasty, the sulfur,
Yeah,
which
all the impurities.
the rotten egg smell.
Yep.
And it's actually turning an engine, which then is producing power. So that natural methane which normally would just be going up in the atmosphere and going out, we
burn it in a flare.
Burn it.
Just go in the atmosphere.
So we burn it in a flare, and it just goes away and not being used for anything. We're now turning it into power. We're turning it into something that's now saving us money.
Yeah.
That's what I think is so cool about this. Any of the energy neutrality at a wastewater treatment plant is we're taking something that's wastewater treatment's been around for hundreds of years, and we're taking something where I remember when I first started in wastewater, somebody would go out there every morning with a propane torch and kick up the flare, and you just burning it off. But now,
Is that a Crest Hill?
yes, now we have the ability to take that gas and really reuse it for something that like you mentioned, they're making money, taking the waste and saving money, not paying it to their electric utilities. It's a double win.
I think the other part is I didn't even cover the heat, the CHP for heat and power. So with that engine, it produces a lot of heat just with the combustion engine. And to keep that engine cool, they have like a internal recycle loop of hot water that pulls all the heat from the engine so it doesn't overheat. we capture that heat and we usually put that in the hot water system for the wastewater treatment facility. Typically, it heats up the boilers that is used to heat the sludge to maintain temperatures for anaerobic digestion.
So we're using the boilers to then heat up to keep the anaerobic bugs happy, to make sure they're producing that methane gas.
Yeah, so CHP would heat up, that water would go into the heat exchangers, and then we would heat up the sludge. So we're not using our boilers, and that's also the saving grace there, because we're not the boilers typically use that biogas or natural gas to produce that heat.
So as utilities start to develop their 10, 20-year plans, how do we start to shift energy neutrality into those conversations? Is it at the capital planning stage, or is it when we start really looking at the project development?
I think the way that is the most successful is, like, you need a champion within each district, municipality, city that is like really leading the charge. And I feel like we need like people to take that journey, to go down that path. Like putting a $5 million in a capital plan, like, may give you the budget to do some improvements, but like that's not the way to get to energy neutrality. I think there are like a lot of like simple steps. Like I think you do some baseline assessment to kind of see what you have. That will kind of give you an idea of what you need to do. You need to do those improvements, and then you need to like have some sort of metric to see how we're doing, to kind of like realign those goals. And then just like iterative process. As you look maybe at like a 5-year scale, you can say, oh, we need to do this next, or we need to do that. And I think with all of like the new permit limits coming out, new technologies for treatment, there's opportunities for energy efficiency there. So I think it kind of like lets you reevaluate and kind of reset those goals with the alignment of, hey, how can we do this more efficiently? Or how can we produce more energy? Or how we can better utilize some of those resources in the community, whether it's a hauler coming in, whether it's food scraps from a college. We do a lot of sanitary districts and water reclamation districts in college town. So there's a lot of like food scraps with all the cafeteria.
So the first step maybe isn't saying, I want to get there. It's finding that person, or that what was that problem? What's that problem question of, hey, we know we have a lot of restaurants in town, and we have a grease problem in our collection system. What are some small steps we could take? Which really gets us into the next question of infrastructure is getting older. Wastewater treatment plants are getting older. Collection systems are getting older. How do we balance the aging infrastructure needs with the investments of energy generating or energy saving projects? If you're, I assume people have come to you and said, Brent, our plant's falling apart. We need to Band-Aid it together, but this energy savings is really cool.
Yeah, I think the like energy savings, energy neutrality, I almost think that's like extra credit in school. Like you got to get all of your subjects in order. You got to have all of your papers written, all of your like tests. Like you got to be in a good spot. Essentially, your infrastructure needs to be in a good spot, because what you're doing is you're allocating like funds for a non-critical process that isn't related to your core function. It may, if like that community has a mission statement that talks about like sustainability and energy, but it's not related to the treatment of water. So the thing that I really want to emphasize is like we need to provide adequate funding and planning so that their core functions can be in a good spot, where then they can look at doing some of these like cool things and like maybe some of the more ancillary stuff that can really see a benefit, but you got to have your core function like in order. Your house has to be in order.
And this journey, it's not, like you mentioned earlier, it's a journey that you have to go. It's not just one project. It's going to be a couple projects, building upon each other, refining the process. And I think, as you've seen some projects you did 10, 15 years ago to projects you've done in the last 2 years, what's something that you've seen today that you never thought you would have seen 10, 12 years ago that really has surprised you?
Gotcha. I'm going to step back 1 second.
Okay.
And I think I liked when you restated like the path or journey. When I was thinking about this with like energy neutrality, like it's almost sometimes viewed as like black or white. Like, did we get there or did we not? And I almost think it's not like whether you get there or not. It's like that path that you take because I think that path that you take, like a lot of plants like aren't going to be able to get to energy neutral. But I think it's the path of like seeing where you can get to and like how you can get there. Because that's going to give them the insights, and it's going to allow them to critical think of like, do I need to operate for these 6 hours of the day when energy costs are this? Or can I like change my mixer cycle to reduce that, or raise some wet well levels, or change my diffuser aeration rate? I think a lot of that engages operators to think about these things and understand it, to continue that evolution so they can continue to get better.
And to your point, they may not get to neutral, but they're taking a step in the right direction.
Yeah, 100%, which I think is what we're like striving for. And I think that's kind of like what they're passionate about as being an operator.
Right. So what have you seen that's changed? What have you seen that now shocks you that you never thought you would have seen 10, 12 years ago?
Yeah, so as Mark said, I've been here 21 years. I did like 3 summers as an internship. And I feel like there was like, I'm going to like quote like a Taylor Swift thing.
Okay.
Was that on your bingo card today?
No. Gosh, no one.
Benson Boone, maybe?
That's a little better for me.
Yeah. Okay. I feel like there was like 4 big eras of like how I was seeing like operators and wastewater treatment plants like interact. During my intern years, I was out in the field a lot. I was on construction sites. I was like just watching people operate things. And as you know, in construction, it's always like crazy, like to maintain operations. And operations like this was back in, I don't know, in the 90s.
I really hope they cut to like the dinosaur.
Oh, gosh.
With yeah, I really hope they cut to that.
So there was a lot of like just like turning of valves, moving gates, like kind of tweak a valve. So very manual, like it's mechanical. And I remember like I'm designing these gates and these like rim turn strength, like making sure it's like operatable. So that was like the phase 1 of like very mechanical. And then I remember this was even before Crest Hill. This was like my first design, and maybe it was Crest Hill a little bit. The next era was like, we're getting into the era of monitoring a lot, having a lot of instruments, and really like being able to get a lot of information.
Right.
Like starting to see that information. Maybe not everything's manual, but at least we're getting information. So we're putting instruments everywhere. We're getting information, but it's like, what do we do with it? So like that was era 2. Era 3 is like overload of information. So we have all these things. So then we're like creating dashboards. So like a public works director can see this, an operator can see this to help them do their job better. So we're like managing all this information. And then I feel like we've kind of been stuck there for a while. Not a while, but maybe like 5-6 years. And now we're in this like age of like, there's information everywhere. It's like AI. Like operators are like, how do I operate my plant? And it comes in from AI. Right. So there's like, we've went from like this direct source of information from monitoring instruments like within the treatment plant to having it a little bit filtered through like your dashboards for better viewing. And now we're just like going out to the internet. And
now it's streamlined.
I know.
You go into a plant today where we used to see chart recorders and graphs and tables, and now it's like you get one little table and you're like, how's your plant running today? Well, the chart says here, and sometimes you're like, well, did you go look at it?
Yeah.
You know, and so to that point, now that we're in this 4th era, on the operations side, a little bit, you need to go back to the first era to really learn how your plant operates and not Google it.
Right. The other thing is, and like throughout my career, I was like, as a younger engineer, I was like very like risk averse, like a good engineer should be, where I was, and maybe that's good for all like the younger engineers. You just start doing the basics that you like know are going to work. But as you've done all those things and as you're like growing, like, I don't know if it's like I'm craving taking risks, but I know that there's some cool opportunities out there where you want to do like new fun stuff, or maybe it's not as like tried and true. Right. So I would like encourage younger engineers to like go out there and take risk. Like we have a QA QC process. Like there's a lot of checks and balances where if you make a mistake, like it's going to be okay. And that's like, I talk to my kids about that, like failure and like making mistakes. It's like accelerated learning. Like,
yeah.
You're going to learn something, and like everyone's going to be okay afterwards.
Yeah.
Hopefully.
So to wrap up, you know, we look at the future of energy neutrality in the wastewater world. And do you think the future will be energy neutral, energy positive, something else crazy? And what will utilities look like in 20, 30 years for the ones who are working on energy neutrality and the ones who aren't?
I think in terms of the future, I think energy neutrality is going to maybe like, I don't know if it's going to go away, but I think it's going to be a little bit different. And I think it's going to be different just because we're going to be looking at more than energy. I think it's almost going to be like a management of resources where maybe you're looking at a holistic community of how they're utilizing some of their heat, or how they're collecting all of their fog or food scraps, or how they reuse some of their water. And I think that's another thing that's kind of gaining traction now, is that like that water we're discharging to the river is probably cleaner than what's going into the river. And we're seeing a lot of water shortages. So I think some of that direct water reuse is going to be useful. And then we do the same thing for biosolids.
Right.
So
we're really more looking at a whole picture, not just methane gas, not just heat, not just electricity.
Yeah.
It's going to be every resource on planet Earth within a community.
Yep.
Well, I had a great conversation. I appreciate you coming down.
Are we done already?
We are done already. So thank you for coming down, and we appreciate your time.
Really appreciate it, Mark. Thank you.
Thanks. When I sat down for this conversation, not knowing how much went into making a wastewater treatment plant energy neutral, from the process, from the people it takes, from the engineering standpoint, and it just having to be a holistic approach that a plant and a community want to undertake. We are a generation who's looking towards the future, towards renewable resources, and energy neutrality is one of those things that's going to continue and really be that wave of technology into the future for our wastewater treatment plants. For our entire team here at Baxter Woodman, like, share, subscribe. Have a great day.